皆様こんばんは。
Good evening or good morning, ladies and gentlemen. To hear the simultaneous interpretation, please select an audio channel by clicking the interpretation icon at the bottom right of the Zoom screen. This program is organized by ISIC Japan and produced by Bloom Pacific and Versatech. Our sponsors in alphabetical order are BAE Systems, Lockheed Martin, and Raytheon Technologies. Interpreters are Christopher Field and Paul Hershey. I would now like to turn the floor over to ISIC Japan Chairman Masanori Nishi, who chairs this Defense Industry Forum on the topic of the digital imperative, accelerating change in aerospace and defense. Welcome to the ISIC web seminar. I am the chairman, Masanori Nishi. Today, we have invited Dr. Roper from the United States. The term digital transformation is frequently used around the world in this age of pandemics, but many of you may feel that it's a word that has somehow gotten ahead of its reality. At the Pentagon, Dr. Roper has been involved in a wide variety of activities, such as changing cumbersome procurement procedures to be more in line with the times, promoting the use of the latest technology in the development of equipment, and reflecting such concrete digital transformations in the formulation of future strategy. A very wide portfolio. Although many in Japan may not be aware of it, the Rhodes Scholarship at Oxford University, which Dr. Roper received, can be described as perhaps the most prestigious scholarship program in the world. Recently, Rhodes' reputation has been tarnished by criticism of his racism for being a leading figure in imperialism. And there is a movement to remove his statue at Oxford University, but the man who created the scholarship, Cecil Rhodes, made a huge fortune in South African diamonds in the 19th century. I actually myself was also a beneficiary of the Rhodes Library when I wrote my master's thesis. The two panelists who will be discussing Dr. Roper's talk are Mr. Yasuhide Nakayama, Vice Minister of Defense, and Mr. Hiroyuki Hatada, who has experience as the Director of the Aircraft and Weapons Division of the Ministry of Economy, Trade and Industry, and has a very broad and deep knowledge of defense issues. Thank you.
Well, depending on where you are in the world, either good evening for those in Japan, good morning for those in the US, and good afternoon for those in the UK. So what I'm looking forward to talking with you today is something that made me exceptionally excited during my time running the US Air Force and Space Force acquisition, technology, and logistics programs. And that is the confluence of several digitally focused technologies that opened the opportunity for us to change how defense acquisition works, arguably for the first time in over 50 years. And so my goal for today is to share what made me excited and what I hope lies in future for the US and all of our allies and partners as we harness these digital technologies for defense programs and even for our commercial enterprise. I'm excited about what the future holds. So my hope is to leave lots of space for questions today, because your questions are much more important for you and much more interesting to me than the things I've already learned in the programs I had the privilege of overseeing. So to begin, it probably helps to put a historical backdrop on why there is an opportunity to change the way we build things, specifically the speed at which we can design new systems and move them into manufacturing in a way that we have not been able to do before. And the terminology is not settled worldwide, but the most common summary of these technologies is fourth industrial revolution. I didn't know that term when I entered my last job. I entered it knowing that the Air Force had had a problem historically developing software for military systems. And I was very focused from day one, changing our enterprise to not just be good at software, to be truly excellent at it. Because increasingly, software provides the cutting edge that militaries take onto the battlefield. And I'm delighted to say that the Air Force and Space Force did an excellent job of harnessing commercial technologies like cloud and later Kubernetes, which is a very important technology in this fourth industrial revolution context. But the speed at which you can develop software using modern development technologies did not move into hardware. So we had software that was very agile and adaptable, which was a huge win for our services. But the hardware that we took onto the battlefield remained very static and dormant. So I was looking for an opportunity to speed it up in the same way that software was sped up by agile development. And luckily, there is a new technology that's been perfected in a few commercial enterprises that crossed in to military procurement precisely as I was in my last position. And once I saw it and the promise that it offered, I tried to learn as much about it as I could, talking with industry experts so that I could wrap my arms around how far we could go towards harnessing this technology to revolutionize the hardware of our service in synergy with software so that our total force was adaptable in the face of a future that is likely to be very volatile and where the capabilities our adversaries could bring to the battlefield are unpredictable. Given that future where you don't know how to forecast it, the best thing you can do is to get your military, both its procurement arm and its operational arms, ready to be agile and adaptable so that no matter what is encountered, you're able to meet it head on and respond to it in a way that leads to victory. The technology that focused on hardware doesn't have a worldwide accepted name either, but the one most commonly used is digital engineering. And I first saw it in a US Air Force program called the T7, which is a replacement for all of our trainers. Now, this is a program that was important to me because training airmen to fly airplanes is what an Air Force does. Without that, you're not much of an Air Force. So pilot training was exceptionally important. But when this program was announced, it was so far below cost, almost $10 billion below what we estimated. And additionally, the industry partner, in this case, Boeing, was able to go from a clean sheet design, drawings on paper, or in this case, designs in a computer, to airplanes flying in the world 3 years later. And that hadn't happened since the 1950s. And so stepping back from that announcement, I thought, this is so much bigger than a training program. This is the tip of an iceberg that could be much bigger in terms of a change for defense acquisition. And so I started learning about that program and more generally about how digitally engineered programs work. And the best examples in commercial industry were in the automotive industry and Formula One racing. And many company leads were gracious enough to share with me how they had harnessed digital technology to fundamentally change how they design and produce new systems. I found the obstacle in sharing my enthusiasm for this new technology is that computers have been used in design since the 1960s, and model-based system engineering has been used since the 1990s. So when you went to a defense industry expert or someone in the Pentagon and said, I see something completely revolutionary in digital engineering, the answer I most frequently got was, we've been using digital engineering for decades. And so I realized I had to actually put thoughts down on paper and explain why this is different and exciting and something that we have to harness, because like a surfer, the wave is coming whether we like it or not. And our choices are simple: either be ahead of it and use its energy to propel us forward, or be behind it and watch as others enjoy the benefits it gives. We cannot be ambivalent on this subject, because its power for building things was unquestionable to me. It will be harnessed for commercial enterprise because of the advantages it gives. And so as a military procurement official, keeping up with commercial enterprise was a concern I had from the day I entered the job and kept till the day I left, ensuring that the military did not fall behind. And in the case of digital engineering, we weren't behind. We were there at the beginning. So I'd like to explain what it is and why I was so excited about it, and what I think the future holds if we harness it equal to the way we've harnessed agile software technologies. The best example that I can give in brief, without referencing the movie The Matrix that you can see behind me, is that digital engineering in this decade, when it's brought into its fullest representation, is more like virtual reality. But unlike virtual reality for entertainment, for video games, this is virtual reality for design and production. The models that drive the virtualization are so realistic and so anchored by real-world data that you can make decisions in the digital virtual reality that you would have normally only been able to make by doing things in the real world, designing physical systems, bending metal, prototyping, and testing. These things take time and money to do. But what I saw in programs like T7 and ground-based strategic deterrence and our next generation air dominance program was an increasing amount of virtualization. Things that we had normally done physically were being done virtually. And I also saw that not only were they being done virtually, they were being done better. And what I saw by having a virtual representation of design and production that were linked together in something we called a digital thread, this idea that the models for design were connected with the models for production in a way that lets you flow from one to the other consistently. And we worked hard to ensure that that digital thread was not cut, because cutting it would take away all of the power of what the digital thread gave, which was the power of concurrency. Now, I don't know if that term will translate well into Japanese, but concurrency is almost a swear word in defense procurement in the US. If you had concurrency in your program, you would be lambasted by Pentagon officials and members of Congress. What concurrency is doing too many things in parallel. You're designing your radar system and your fuselage and your wings and your mission computer systems all at the same time. And what happened historically in defense programs is when you had too much concurrency, too many things happening in parallel, when they all came together, the integration challenge was so daunting that it rarely succeeded. it was effectively pushing greater and greater risk to the right of your schedule, sweeping it under the rug and hoping that things worked out, and they rarely did. So what acquisition officials started to do to programs was remove concurrency, made things happen in serial. Well, that did horrible things to defense acquisition. It slowed down the programs because things in serial are going to be slower than doing them all at the same time. But even more damaging, it started removing time for engineers to be engineers. Because when things are done in serial and you decompose a complicated weapon system into its subsystems and subsystems all the way down to the fundamental components that make it, the engineers that are working in those fundamental components and subsystems have to lock down their design so quickly in order to pass something that has no integration risk to the next level of design up. And so time to be engineers slowly eroded from US defense programs, and engineers effectively became integrators. But in this era of virtualization, where every part of the system is represented virtually, concurrency becomes a strength. You can have engineers designing all parts of the system at the same time, and the models ensure that what they're designing can be integrated together. It does the hard work of integration for you. And aside from shrinking the schedule, because you can do things in parallel, it gives engineers more time to solve problems. It truly is a win-win. So that was one thing that I saw from programs that were using digital engineering right, that were revolutionizing with it. The other thing I saw by having this digital thread was that you could begin working on production far, far earlier than having a physical system to build. And in the case of T7, Boeing was able to attack something called learning curve, the process by which people learn to assemble the aircraft. Historically, it follows a curve, and just like any human endeavor, it takes people time to learn to do things without error. And historically, it took about 100 aircraft for all of the learning to be retired. Well, in the case of T7, the first aircraft was built at the same quality level that 100th aircraft would have been built historically, meaning Boeing built the first aircraft as if they had already built 100. They retired learning curve. They defeated it in the virtual environment, so they didn't have to learn those lessons in the real world. And that saves time and money. They also did many other things, like reduce the amount of cost that
その他にもですね、コストを削減したり、しました。それ他にもですね。
Just suffice it to say that when you have a true virtual reality representing your design and production, you can start doing more and more in the virtual environment where the cost of trying things is just the cost of electricity. There's very little regret to doing it. And the only thing someone has to do
大変失礼しました。で、その行わな
is have proper anchoring to be trusted as a authoritative source of truth. And that's the real art of digital engineering. You can't just simply grab models and use them. You have to know that they represent reality. That's the challenge. But once you know they adequately represent reality, they unlock nearly limitless potential to start doing things in the virtual environment that would have taken years and millions of dollars to do otherwise. So what I left my focus on the T7. I then went and talked with the automotive industry, which has impressively harnessed this technology. I talked with Formula One Racing that uses it to ensure they can compete across a very varying racing cycle, dealing with lots of obsolescence of parts during the racing circuit, as much as 80% on some years, which is impressive they can design around it. And then I talked with industry experts and economists who summarized all of these digital technologies as a fourth industrial revolution. And I realized that we could no longer think of digital engineering and agile software as innovation, that we needed to think of them as imperative. Because if it's true, and I believe it is, that another industrial revolution is coming and that it will change the way commercial enterprise works, then defense procurement cannot be left behind. Or increasingly, we will become a shrinking island that has access to less and less of the world's technology because we don't use the same techniques they do to build things. And so that fourth industrial revolution is simply hallmarked by what I would characterize as coming full circle. Before the first industrial revolution, everything was done via artisanship. And so specialization of what was built was indicative in everything that was built, because artisans built them for the particular purpose they were requested. Then in the first industrial revolution, the factory was created and some amount of specialization was lost to increase the amount of production that was possible. The second industrial revolution took this even further with the assembly line and broad mass production aided by the railroad and the telegraph, so that products could be built locally but sold across nations, even across the world. But specialization of what was built was lost. And then the last industrial revolution, the third, brought in information technology, the microprocessor, and all that computerization has offered. But when you bring all of these together and think about what the virtual reality approach to designing, that includes both design and manufacturing. And once you've built your system, your physical system can still be connected to its digital twin the rest of its life and continue to evolve digitally as it evolves physically. The power of that concept appears very much like the Internet of Things we have today, but just taking that idea into design and manufacturing. And what I believe will happen, as do most experts, is that when you bring Internet of Things technology together with virtual digital engineering and agile software development, that you will have a way of producing systems that goes through much faster design cycles. And I've seen that in our Air Force and Space Force programs, that you will move from design into production much faster than historically possible. And because of using the digital tools to simplify how things are made, going into a large scale mass production will no longer be necessary for economies of scale. You already see this being the case where additive manufacturing is being applied in new ways to programs, that it changes the equation for whether you need to mass produce something or whether you can afford to build it in smaller quantities and specialize it as you go. If these things come together as anticipated, the fourth industrial revolution will be characterized by very fast design cycles that are being fed by data from the systems that were built in the previous cycle. They will be characterized by moving from design into production very rapidly, but not moving into a mass production, being able to build things with high specialization but low quantity, and being able to do that affordably. And in that way, we've come back full circle to where artisanship is possible, but not like the artisanship of several hundred years ago, digital artisanship, where designers work digitally, where specialization happens digitally, and technology removes the imperative of going to mass production to see economic order quantities that make the prices affordable. If that is the case, this is a wonderful technology trend for militaries that are competing against adversaries that have greater scale than they do, more money, more assets to bring to bear. Because the trend I just described, this fourth industrial revolution, which is very adaptable and agile, is precisely what you'd want to beat an adversary that has more scale than you do. Whatever they bring to bear, design something new that challenges it, and then design the thing that comes after that faster than their ability to understand and counter the system you just fielded. It is an agile, adaptable framework that defense procurement has been missing. And given so many industries are wrestling with how to harness this fourth industrial revolution trend, I believe that the imperative will force them to become good at it, that industrial bases and economies will change because of it. And if militaries are wise, they will paddle ahead of this wave and reap all of the benefits that adaptability will give. But if they're not wise or foresighted, they could easily fall even further behind commercial technology trends than we are today. This was a passion for me when I served in the US government, and something I am still passionate about, helping militaries that are our allies and partners understand and harness this trend, so that when the wave does break, it propels them to an exciting future where who knows what's possible. This new digital art form, its future isn't written yet. It'll be written system by system based on what we build with it. I hope this is a good introduction and whets your appetite for what's possible, but I would very much like to hear your questions and try to answer as many as I can. And I'd also like to thank you for allowing me to speak to you today. It is an honor to be able to share what I've learned with people around the world, and especially important allies that we have in Japan. Thank you for your time and attention today.
Thank you, Dr. Roper. I also worked almost 40 years in the Ministry of Defense, and the issue of the system for acquiring weapons was quite old, dated, and that was a big worry of mine. In Japan, the basic idea is to look at the commercial industry as we prepared our processes, and the accumulation of software, for example, was very difficult in that way, so that we would look at that. We have to think about how does the country determine what the price should be for software? Ultimately, we could only go with market prices, is what I thought. This is going to be a new issue for us, but if it's a general purpose program that then becomes a specialized military program, using the market price as an indicator is not a good thing. So for acquisition in Japan, we have to think about that. And we also have to think on software, and then on the hardware side as well. The timing to build things takes a long time, and how do we speed that up? How do we accelerate that? So these are very serious issues, which I think the country's defense industry is suffering from. So I would like to talk about, I'm not the one who should be talking about this. I would like to introduce Yasuhide Nakayama, who is currently Vice Minister for Defense He has a very long experience with and deep knowledge of acquisition of defense weapons. So if I could, I would like to ask you, Dr. Nakayama, to talk about your experience, your thoughts, and your reactions to Dr. Warburg. Good evening. We are now 9:32 p.m. in Japan. I'm very happy to be able to uh, share this time with you. For I think we have a common, first of all, common enemy across the world, which is to defeat coronavirus and to end that as soon as possible.
So I very much hope to be able to engage in joint activities with all of you listening to Dr. Roper today about digitizing manufacturing, the so-called digital transformation. This has to do not just with the defense industry, but I believe that this is a trend that is affecting all of industry. In the defense industry, with respect to design, manufacturing, and sustainment, I think that there will be great impacts. That is our understanding. As to the Ministry of Defense and the self-defense forces, we want to procure good items in an efficient way, and we think that that is indispensable for the safety of our country. And thus we must increase our understanding of digital transformation. At the DoD, there has been work done on digital transformation. To hear Dr. Roper talk about his direct experience is very valuable for us. So we're so grateful for this opportunity. Now, when you look at the reduction of costs and the speeding up of schedules for the development and manufacturing of defense items, it's wonderful. However, we also think that a large initial investment is required. And I wonder what kind of actions you took in order to encourage such a large initial investment. And also to digitize all the design information and within companies and between companies, you have to send this information over networks. And we understand that it does have very many benefits, but we wonder about the information security risks. I think that it's undeniable that such risks do increase. So we wonder what kind of information security measures the US government has encouraged industry to take, and would be happy to hear your thoughts on all of those questions, especially with respect to the defense industry. Then, in promoting digitization, individual pieces of equipment and softwares, it's not just getting a physical base. You also have to change the mentalities of all of the people involved. And I wonder what kind of things you have done and intend to do. Be happy to hear your thoughts on that as well. The US and European countries are very active in pursuing the digital transformation, I understand. But I'd be curious to hear about any differences of approach between the US and European countries, and also any examples of individual projects. And as to the next fighter, with the prime contractor, we would like to make the development digital. If you have any advice for us in that area, I'd be very happy to hear. But as to the efficiency of maintenance and sustainment, it will be necessary for each of the units to be able to analyze all of the information. And we wonder what organizations have to be built to do that. In the DoD and the US Air Force, life cycle management depends on a piece of software, I understand, that is called product lifecycle management. And for we at JMOD, we are considering something similar. But if you try to introduce it all at once, that could cause confusion. Perhaps a step-by-step approach might be better. We wonder exactly how you went about doing this. I'm afraid I asked very many questions, but I'd be happy to hear any reactions. Thank you all so very much.
中山先生、大変ありがとうございます。ローパー博士、非常にたくさんの質問が。
There's a huge number of questions to you, Dr. Roper. How should we handle this? It's of course all right not to answer all of them necessarily, but from your standpoint, perhaps you'd like to speak to what you consider the critical ones of those.
Interpretation going on. I'd like to try to answer the questions if possible. Is it possible to mute? Thank you. Very good questions. And it's very clear that you have anticipated the implementation challenges that come from digital transformation. And yes, there are challenges. Nothing that pretends a better future can be achieved without effort. In terms of the initial investment that we had to make, most of what was required for our software transformation was also required for the digital engineering transformation that brought hardware and full system design to the table. So that required us having an enterprise-wide cloud that could run at multiple security levels that were consistent security level to security level. It required that we have an enterprise-wide development platform that made commercially available tools for software design and later hardware design available, so that coming to work on a defense program was no different than, say, going to work for an automotive company and needing to design a new automobile or look at its manufacturing, that the same tools would be available, but hosted in a way that allowed security to be enforced. And right as I left the Air Force, we were adding streaming data similar to the way the internet works, so that aside from having the ability to have models and software development tools, that you were getting data that was either coming from other defense programs or your own program, so that you had a feedback loop, so that a digital twin, the digital representation of the physical system could be connected to that physical system and they could evolve together. And if the Air Force and Space Force continue the trend, I expect that they will add analytics and artificial intelligence, all available as a service across the broad enterprise. So in terms of the investment, this idea of cloud platform, data, models, analytics, and AI is sometimes referred to as a tech stack. I know that for our interpreters may be difficult to translate, but the idea is it's a development environment that has different layers that work together consistently. That was the required investment. But because the layers of this digital development environment are all driven by commercial technology, the cost was not challenging. The security challenges, as you referenced, were the most daunting thing. We spent the most time working with security officials to ensure that having all of this data co-located could be done safely without exploitation. And I would predict if Japan takes on the similar transformation, security will also be a challenge for you. But it's one you can overcome. And I'm confident it's one that the US and other allies and partners would be happy to share what they learned. In my case, learned the hard way, what didn't work, and then ultimately what did work. And then finally, once you've created this tech stack, this integrated digital development and manufacturing and even sustainment environment, then you have to train your people to use it. And the training of people was increasingly a limiting factor, because having the tool is not the same as knowing how to use it. And so the way that we approached it was similar to what you alluded to. We could not transform the whole Air Force and Space Force at once. So we selected key programs that were new programs where the government had the ability to determine how they would be built. Be very difficult to do this for something you've already built or that you have already determined the relationship with the vendor. So we picked new programs, and we picked enough to be meaningful, but not so many as to be overwhelming. So T7, ground-based strategic deterrent, which is a Minuteman III missile replacement program, next generation air dominance, our B-52 bomber re-engine program, and a few others. And that's where things were when I left the Air Force. A handful of programs, about 10 in total, attempting digital transformation so that we could learn lessons from their efforts before we expand across the entire service. You referenced product lifecycle management. That is absolutely a part of the transformation, because once you have built a digital thread that goes from design and production, you would want to bring in sustainment and maintenance and pull the thread all the way from the very inception of the program, all the way through its operations and ultimately into the retirement of that system. And could you imagine training maintainers to do maintenance on an aircraft that doesn't exist yet using virtual reality? I imagine we all can see that. And we were doing that in the Air Force, training maintainers before the physical system was even built. And I expect that when those physical systems do come into existence, that we will find that it takes far less time to train maintainers to be ready to maintain them. But we still have to prove that. So the product lifecycle management will simply add at the end what I've already seen digital engineering add at the beginning of the life cycle in design and early production. In terms of the difference, you also asked the difference between the US and Europe. Everyone is trying this, and I feel like I am helping everyone that's attempting this, which is a wonderful place to be. I really enjoy helping nations and companies wrestle with how to do this, because it's not, the promise is great, but the challenges are great as well. What I would say is that this is so new that there isn't enough fidelity to determine what the differences are yet. What's exciting is that many nations are attempting this. And my hope is that allies and partners will share the lessons they've learned. They don't necessarily have to share the details of the system they're building, but share what they've learned about digital transformation itself, so that after several nations have picked a small number of programs and attempt to do things differently, faster and more agile, and some things will work and some won't, that those lessons can be shared, and that when the next round of programs is attempted, that everyone is better and smarter because of the first round. And I expect it will take several iterations to really learn how to harness these tools. But the good news is that to harness them, at least to begin, in design and early production, everything is happening digitally. So the cost of learning is just the cost of electricity. And the biggest risk, I think, is simply not having people trained to leverage the tools. If you were to ask me overarching, what's the biggest risk? Aside from underestimating security, it's not having proper training of people so that they can truly harness the potential of what the tools can give. But if those two things are done, my experience is you give smart people time, you give them top cover, empowerment, and give them some new technology with revolutionary potential. Smart people find a way to unlock it.
Thank you. Now that we're in the digital age, the speed of change has gotten very fast. Even if this is right in front of us, the things that we have to, we're now, what you've talked about is very important, because I think Japan has entered a totally new age in terms of what we can learn. Next, I would like to talk about talk with Mr. Hatada, who is from the METI. He has had a long experience with responsibility for policy, and in particular is well-versed in Japanese aircraft and weapons. So has great concern and interest in those issues. I would like to ask him to please speak to us. Good evening. My name is Hatada. I'm Director of the Americas Division of the Ministry of Economy, Trade and Industry. Today, I'm honored to participate in discussion with leading experts on the important topic of digitization in the defense industry and aircraft development. It's been very interesting, and I've been very stimulated by what I've heard so far. So I'd like to make a few comments, if I could. My first comment is that not limited to the defense industry. This is a natural and required trend in industry in general, not only for development, digitalization of development. I think involves three connections. It has importance in these areas. The first connection is the connection with partner companies. The ability to do digital development is extremely important to all industry areas, and at that point, and requires a lot of coordination with partner companies. The second connection is the connection with foreign countries. The Japan-US summit in April, Japan-US supply chain cooperation was one thing that was agreed upon. To promote this, it's important for each industry in both countries to promote the digitalization of their industrial infrastructure. Also, I don't have time to go into the details about defense equipment per se, or defense equipment transfer today, but the most important thing is that technology needs to be required by the other company. I believe that digitalization will become the necessary condition for such transfers in the future. My third connection is the connection between each phase or aspect of the product life cycle. When you're developing and manufacturing and operating products, you need the feedback from those results. All of those require digitalization. I think that will promote the speed of innovation as well. So it's certainly the case that digitalization is a trend in all industries right now. On the digital industrial base, we need to have a flexible digitalization base in Japan. On the next generation fighter, we are developing our own operating system. The reason for that is to have flexibility in our configuration systems, and we want the ability to change our own abilities. That's a very important point as well. The environment that we're in, our needs are changing, and so we need to be able to change our abilities to respond to those changes for our defense, I believe. When you think about digitalizing your development capabilities, that Japan doesn't operate, or for Japan to be able to continue as an independent country, as an autonomous country, I don't think we have to internationalize completely, but we have to think about the systems that are used in foreign countries. I would have my first question to Dr. Roper, therefore, to be at coordinating between allied countries. What do you see the infrastructure sharing roles? What are the points of infrastructure that we should be thinking about as we coordinate and with our allies? And then another point is, third point that I have is that particularly in Japan, we need to have a synergy with civilian industry. I think that as we move towards digitalization, there's a huge investment and a long return time required for that to pay off, and that's a reason why we need so much synergistic effect with civilian industry. I would like to introduce the example of a past example of something called J-Forge. This was something which was created in Okayama to do a forge. It's a factory that does forging at the very lead of the world leading forging capabilities that the government coordinated with industry to create. It was particularly oriented towards jet engines. We introduced a lot of new technology there. There was also coordination between industries, between government and industry. So the business case was made, and the industry was convinced to make those decisions for making large investments. And those are, we are trying to exploit that now for the next generation fighter jet engines. So that's an example where we have maximal synergy between government and industry. And I think we should be referring to that in the future as we go forward. And it's not just for aircraft. I think we should be able to get this synergy in other areas as well. So my next question would be on this digital infrastructure. As we try to create a defense industry, how do we get that maximum synergy? What is the easiest way to achieve that synergy for defense industries with civilian industry? Another comment, my fourth comment, as we move towards digitalization, we need to have, I think, a support system that takes into account how industry actually behaves. We have seen a lot of withdrawal of from the defense industry by companies. They say their understanding is that they're not getting paid enough by government. So they see it as, the industry sees it as an industry where you don't make money. So why does this happen? It's because on the Japan side, on the government side, the government looks at the percentage profit per sales with respect to sales, whereas the people who run the industries, the management, is looking at cost of capital, risk to assets, profit to total net assets, total assets invested, and so forth. Those are their indices. This is a very unique to Japan area, but it also shows that there is a high reliance on civilian industry, civilian sales, even in defense industry. So that's why we haven't gotten dedicated to defense industries because the risks for capital is not sufficient. That's a fact at the moment. So within this situation, as we look to digitalization and try to incorporate that more, it's going to require new and greater investments. We can't just leave that up to industry because, as I said, the problem that I've just been describing is going to become even more pronounced if we do that. And it's not something that industry alone can make a decision to do. So conversely, in this issue, if we could appropriately respond to it, I think that not only would we promote digitalization, but we would solve some of the basic problems that Japanese defense industry faces. If we could make this into a very good illustration of success. I happened to find a report last week that I was surprised to find. It was the Liberal Democratic Party's Strategic Office for the Creation of a New International Order. This is out of really looking not just at the defense, but at the entire economic picture. And what it says there is that government agencies themselves need to take measures which include owning of production assets. That was one of the things pointed out that I found in this report. If such support policies can be adopted, I think that would be very important for the digital infrastructure, digitalization of the manufacturing industry. And then finally, I don't want to forget about manufacturing capabilities themselves. No matter how much we digitize development and succeed at that, ultimately, the question of how to physically manufacture remains. Physical manufacturing capability is also the source of innovation. We have in the past had a very bad example in the semiconductor industry. We thought that we could focus on design in the semiconductor industry. And we're now paying the price for that, I believe, for leaving manufacturing to others. We don't want those things to be repeated in the area of aircraft or other defense industries. I think that's something we have to keep in mind and look for synergies. Finally, we want this physical excellence in manufacturing and as well as the digitalization capabilities. And I would like anything you can tell me about the synergy effects that can be created between those two things would be very helpful. Thank you very much for your talk.
多田さん、どうもありがとうございました。
Thank you very much, 多田さん。
Again, wonderful.
Dr. Roper.
Yes, go ahead.
In terms of the development of Japan's next fighter, I think this is something that we cannot avoid in the U.S.-Japan relationship. There's a gap between the U.S. and Japan in the defense industry structure. There's this gap in the amounts of investment that are being made between the two countries as well. So I think that your digitalization, therefore, is going to be very important in that context. We have to fill in all the gaps. Listening to Dr. Hatada's comments, what I'm thinking is, how shall we fill these gaps? I think he's very interested in, I was very interested in his comments about this. So if I could ask you, Dr. Roper, any opinions you may have had about some of the points that Mr. Hatada pointed out. Thank you.
Again, very insightful questions. And so it is clear to me that you have been thinking about this. And so it's a delight to provide answers to your questions and hopefully start a broader conversation about how to do this. I think this is one of the most important challenges that governments will wrestle with for their militaries. And wrestle is probably a good analogy to use, because it will be a struggle to shed old practices to adopt the new ones, but it is a struggle worth taking on. To address the points that were made in the questions, firstly, on the 3 points, the partnering between companies, partnering between allies and partners, and partnering across phases of the programs, as well as with industry. You've got it precisely right. This requires a firm partnership with all involved, where the government is playing a partnership role with industry. And the phases of the program, I want to absolutely underscore, though design begins the life cycle, these technologies will be as revolutionary for manufacturing and sustainment, I believe, and I'll address manufacturing at the end. If you leave one of those pieces out of the puzzle, then you'll do a lot of good, but ultimately have to redress the absence of that piece. It's much better to think the entire life cycle through up front. And I'm very delighted that that question was posed. It's the right way to think. Digitize the entire life cycle, not just design or production or any one facet. Try to digitize as much of it as you can. You asked, what should Japan do relative to working with allies and partners? A couple of recommendations. One, think through security in a different way. Sharing information with allies and partners is a very important function that militaries undertake. It takes an extraordinary amount of time. That process will not make sense in the digital world. And the wonderful thing about technologies like cloud is they're very good at allowing many different encryption keys to be managed so that your data doesn't get intermingled with anyone else's. That same technology ought to allow us to share data between allies and partners faster. And so we need to rethink about data sharing in a digital age. So I would recommend Japan think about that. Secondly, I mentioned the technology Kubernetes for software development. That's containerization. I recommend that Japan consider fully containerizing software development for any military program, because it simplifies getting software from your development environment onto your operational system. I demonstrated this before I left the Air Force, updating our U-2 spy plane software while it was flying. And we even installed an artificial intelligence pilot on the airplane. We would not have been able to do that without containerizing our software, because we could prove that the software would operate safely on the aircraft by running it in our development environment. The technology ensures the development environment is precisely the same as the operational environment. So it's an important technology to harness just for building systems well in the digital age. But what we were also doing in the Air Force was sharing software across different programs and even across services, because the same technology simplified using other organizations' code. I think that's a specific instantiation of software sharing that makes sense in the digital age. So going back to the first point, thinking through how you can share things from data to models to software in a way that moves at digital speeds while still ensuring safety and security is the challenge I recommend you undertake, and would be happy to help share thoughts on how to do that. The other question that you asked was how to, this is also a trend that will impact commercial industry. So how should defense programs engage it? The belief I had in the US Air Force was that we did not need to create a separate version of digitization that was not the same as commercial digitalization, because commercial industry will put more money into improving the technology and defense would be left behind. So we accepted that whatever the current state of commercial technology was, we had to use it as it was, and then to keep up with it as it changes. The latter being a very difficult challenge in the US. Keeping up with commercial technology is not easy, but that is the challenge that digitization requires. You also mentioned business case for industry. So in any endeavor, industry has to see a positive return on investment. And that was important for us as we changed programs to be more agile and adaptable to ensure that industry still made a profit on them. What we wanted them to do was make greater profit in a different portion of the life cycle. In a historical program, industry makes most of its profit in modernizing an older system and in sustaining it. About 70% of all of the money the US Air Force spends is modernizing old systems and sustaining them. We wanted industry to make greater profit designing things. So I would tell industry the money that I had from the US Congress was fixed. There was no additional money to be made. It was my choice and their choice where they made profit. Did they want to make profit in design, or did they want to make profit in sustaining old things? For a cutting edge military, it makes much more sense to give high profit designing new things than sustaining old things. And that's the shift. The money they make is the money they make, but where they make it can change. So still profitable, but just at a different portion of the life cycle. And finally, you mentioned manufacturing and making sure that you maintain excellence in the physical world. Absolutely. Advanced manufacturing is exceptionally exciting. And that's really what enables this strategy to be implemented. A high degree of automation and advanced manufacturing allows you to move from the digital design environment to your digital manufacturing environment to the physical manufacturing environment, and then to spiral back again. So should we be able to design systems that we actually improve and change on a production line that is already making them? Yes, we should. We should aspire for that level of adaptability, just like we see in several commercial industries, the ability to adapt year to year and even within years, depending on market demands. None of that can be achieved if you lose manufacturing excellence or fall behind latest manufacturing technologies, be it automation, 3D printing, or anything that portends to speed up cycle time. It's really connecting that physical manufacturing technology to the virtual design and manufacturing environment that unlocks this fourth industrial revolution that many envision. That you move rapidly from being able to design it, conceive its manufacturing, and build it, but not have to build 1 million units to build it affordably. And we've seen that 3D printing and other technologies that are physical manufacturing technologies are changing the equation of what small batch manufacturing can do. Specialization is no longer expensive in a 3D printing world. How much further we can push the boundaries of specializing and improving physical manufacturing because of the digital environment feeding it improvements. No one knows how far. But I think the task for us is to use opportunities like defense programs to begin pushing the boundaries to see how far we can go. And the benefit, as you referenced, is not just to the military, it's also to the broader industrial base that would take the same lessons and use them for commercial enterprise as well.
ありがとうございました。
Thank you very much. Dr. Roper, you really took great care in answering the questions from both of our panelists. We have also many questions that have come in from our listeners. Unfortunately, we don't have the time to handle all of those. I'm very sorry that we have to finish at this point. But anyway, you have talked about, you have lived in the world and explained very well your experience in the leading edge technology world. And thank you also very much to Dr. Nishiyama, and we appreciate your insights on from both of you. At our next ISIC seminar, with respect to that, we will be announcing that on our webpage. We very much appreciate all of your participation, Dr. Roper, and we are going to end this webinar at this point. Thank you again for your participation.